Uh, Greetings. In this short video, I'm going to review derivatives of exponential functions. There are a couple of formulas that you need to know. The first one is if y is e to the power of x, you have only x here, then y prime, which is also known as dy by dx, is e to the x. So it's the only function whose derivative is itself. So if y is e to the x, y prime, which is also dy by dx, is e to the x. The second formula is if y is e to the f of x, it's not simply x, but it involves a function of x, then y prime, also dy by dx, is e to the power of f of x. So this won't change, but here you have to multiply by f prime of x. You take the exponent, which is a function of x, you multiply by the derivative. In this case, I'm writing that as f prime. So these are two formulas that are useful in differentiating various exponential functions. Now let me illustrate this by means of a couple of examples. Example 1. Your function is y equals e to the power of 4x. I want to compute the derivative of this function. Well, which one should I use? This one is simply e to the x, nothing else. But here, that x could be a function of x. Therefore, here it's 4 times x, so I need to use this formula right here, the second one, the second formula. So if I use that, y prime, this implies y prime is, according to this, copy the function, which is e to the power of 4x, and multiply by the derivative of 4x. The derivative of 4x is 4 times derivative of x, and derivative of x is 1 by power rule, so you have to put extra 4 here. Okay? Notice that this 4 is the derivative of 4x up in the exponent. Okay? Let's try another example. Example 2. In this case, y equals 4 times e to the power of 2x squared minus 4. And I want to differentiate this function. And notice that here it's not only exponential function, but also there's a constant here. Well, you need to apply all the rules that you know of. So if a function is multiplied by a constant, you set the constant aside and differentiate the function. Find the derivative of the function. And that's exactly what we do, the constant rule. So in this case, dy by dx equals, I'm going to leave the constant 4 as it is and differentiate the function. Since it's a function, exponential function of this type, because the exponent is not simply x, it's a function of x, you write the function itself e to the power of 2x squared minus 4, and you multiply by whatever stuff you have, you got to take the derivative of that. Derivative of 2x squared is 2 times derivative of x squared, which is 2x. So it's 4x minus 0. You see that? 2x squared derivative is 4x by power rule, minus derivative of 4 is 0. So if you want, you can write this as 4 times 4x times e to the power of 2x squared minus 4, Or if you can multiply it out, 4 times 4 is 16x e to the power of 2x squared minus 4. And that should be your final answer. Okay? Let's do a couple of more. Let's do a couple of more. Example number 3, I have y equals x squared times e to the power of minus 2x. This function is not simply an exponential function multiplied by a power of x. Okay? So we have to be careful in finding the derivative of such function. It's a product of two functions. The first function is x squared. The second function is e to the power of minus 2x. So you have to use the product rule for the function. So what's the product rule for the derivative? I'm going to write it up here. If y is function of x times another function of x, so y is f of x times g of x, then dy by dx, the product rule says f prime of x gx plus f times g prime of x. Okay? And that's called product rule. Product rule for derivatives. So let's use that. So y prime is x squared prime, that is the derivative of x squared. You must have seen this notation before. Prime also stands for the derivative. Times the second function, you write it as it is, plus first function times, that's x squared times derivative of e to the power of minus 2x. This prime here is the derivative, that prime is the derivative of this function. Now let's do this. So this is where we applied product rule. Now let's differentiate this function as well as that function. First this one. What's the derivative of x squared? Derivative of x squared is 2x. Times, write the function as it is, plus x squared times, you got to differentiate exponential function. It's exponential function. In the exponent, you have negative 2x. So it falls under this formula. Therefore, you got to write the function as it is, e to the power of minus 2x, times, what's the derivative of minus 2x? Derivative of minus 2x is minus 2 times derivative of x. Derivative of x is 1, so it's minus 2. Therefore, it is 2x times e to the minus 2x minus 2x squared times e to the power of minus 2x. You could leave it like that, or sometimes you may have to factor it. The factorization is you have 2x here as a common factor, e to the power of minus 2x is a common factor. So if you factor that, 2x times e to the power of minus 2x, that leaves you 1 here. We removed 2, we removed x, we removed e to the minus 2x, so here you have only x as a common factor, and that could be the answer in the book. And sometimes this kind of factorization is helpful in the future when we try to find the so-called critical numbers. Okay, so that's the end of this short video. And to recap it, it has two formulas for derivatives of exponential functions, one with only x, one a function, and we looked at a couple of examples. And sometimes you may have to apply not only the formulas for exponential functions, but also the formulas you have learned before. Thank you.